Welcome back to our discussion of electrochemistry at the AP/IB/HL level. Now we're talking about 3 different ways to determine whether or not a cell or a reaction as written would be spontaneous. Our first was estimating from the table. Now let's take a look at how we can calculate from the table using those values from the table. Now our 2 half reactions were lead, and I'm going to go ahead and write them as balanced, and I want to show you something. We had lead ion plus 2 electrons going to lead solid, and that would be 2 and that would be a 6. Now the E0 for this, the standard reduction potential for this, was minus 0.13 volts. Now even though I multiplied by a factor, you do not multiply. Don't multiply by a factor. It's already been, it's intensive. It's not dependent on that number. So we're not going to multiply this by a factor. Now our other half reaction was the chromium 3+. So we had chromium 3+ plus 6 electrons going to, and this was a 3 here, sorry, 2 chromium solids. We had a 2 here, and its half standard reduction potential was 0.74 volts. Now again, we don't multiply by that 2, and I'll summarize that in just a minute. Now in our cell, we set this up so that this was our reduction. So what we need to do is flip our lead. So we're going to cross that out and we're going to reverse it so it represents, instead of a reduction, an oxidation. So in that case I would have 3 lead solids going to 3 lead ions plus 6 electrons. Now because I reversed the reaction, I'm going to reverse that sign. So you reverse the reaction, you change the sign. Now all I have to do is add those up. And to get the E0 of the cell, when I add those up, I get a negative 0.61 volts. Now we determined, based on logic from the chart, that this was a non-spontaneous. And that's because the most positive one was not getting reduced. Our most positive one ended up getting oxidized. And so we know it's non-spontaneous. So now we've learned that if E0 of a cell is negative, it's non-spontaneous. If E0 of the cell is positive, it's spontaneous. Does not mean things happen quickly when we say spontaneous. We're talking about if it's spontaneous, there are no thermodynamic barriers at that temperature to prevent the reaction from proceeding to make lots and lots of product. Okay? Now, before we go on to this, we'll do this in the next video, I want to summarize a few things. Let's compare let's compare what we've done. I want to do K because we did that first. I want to compare our equilibrium constant to our free energy to our E0 systems. Now, remember, if we reversed a reaction, with K, we took the inverse of our K. So our new K would be 1 over the K. For delta G, we simply reverse the sign. If it was negative, we make it positive. If it was positive, it was negative. We do the same thing with delta E. We don't call it delta E, excuse me, with E0. We reverse the sign. You just saw me do that. Now, if we multiply by a factor, let's multiply by the factor A, we would raise K to that power. So our new K would be K to the A. If it was delta G, we would multiply by that factor. So our new delta G would be A times our old delta G naught. If it's E naught, we do nothing. We don't multiply, we don't divide, we don't raise to powers, we do nothing. Now, if we add reactions, so like we just did here, we added half reactions. With K, we multiplied. With delta G, we added the delta G's. And with E naught, we added the E naughts. So you see there seems to be a very strong link between E naught and delta G. Well, because there's also a link between delta G and K, we're going to see that we're going to be able to link E naughts with K's as well. But we will do that in our next video, and we will talk about our third way to discuss spontaneity. So until then, this is, as always, your best chem teacher signing off.